Hello everyone, welcome back to Advanced Java Unit 2. This time we are covering Chapter 3, which is arrays, which is probably one of your most important subjects. So arrays are one of the landmarks that makes up, Java programming and computer science in general. So they're essentially lists of data that can use pretty much any data type. So you can make a list of booleans, ints, strings, and even objects. Objects are pretty important to programmers. So you can have enabling creation of like accounts, records, and it's essentially it's a representation of how databases work, how they store data. So what's even better with arrays is that you can modify every single element. So for this, loops and conditions go very hand in hand, which is why you've been studying them. So arrays are a bit of an extension of the data types you've already learned. So you declare it much like an object or a primitive data type. So for example, int so it's this is an array, but it's an extension of the integer data type. So essentially declare it like normal, but you put brackets in front of it and brackets after it. After that, you can specify the elements. So I'm gonna add 1, and then in the next on the list I'll put 2, and then I'll put 3. So this essentially it's an array of length 3. But there's also other ways to declare it. You could specify the number of elements, and then what you can do is you can declare them by hand by using their index. So the index starts at 0. So the first element is 0, so I'll just put it as 1, second one 1, and so on and so forth. Just keep that in mind. However, this is the harder way to do it. And so you don't want to be dealing with these one at a time. This is why you've been learning loops. So you will use loops in conjunction with arrays to help arrays get their elements declared. So keep in mind that anything you don't declare is left at the negated version of whatever your data type. Now what I mean by negated version is depending on your data type. So let's say I do this. So I'm going to print out the last element of this. I added an extra size, and I didn't declare array 3. So what does that output? It outputs 0, but this is an integer, right? So what if it was something else, like a double? So if I did, let's say I do a string actually. Now I haven't declared any elements. And this one will be null, right? So for Boolean, so for other data types, for Boolean it's false, and for double it's 0.0. So it depends on your data type. So once it's declared, this is a defined list. You can't really change the length of the list unless you change the source code and whatnot. But you can copy it into another array, an array that's a little bit larger. So now you use arrays commonly in conjunction with loops. That's because arrays will usually have a lot of elements associated with it. So what programmers do is that they use the for loop to start declaring elements of arrays. So here's an example. So here's an array of size 25. I'm going to declare all the elements to be the number that their element is. So it'll start at 0 and work its way up all the way to 24 because it starts at 0. And so it'll essentially loop through it, and it uses the length property of the array as the boundary, and it'll increment it and go up by an integer value, and it'll start at 0. And it'll just print it out on a straight line. Here it is. So essentially I can work with all of this and like add them, divide them, multiply them together. I can do any operations within this code block, and that's what makes using loops with arrays so helpful. So one technique you can use that's exclusive to data collection is called the enhanced for loop, or the for each loop. So the way a for each loop works, in plain English, it means for each element in this data collection, usually an array or an array list, which I'll get to, you cycle through that and you do all of this, do the operation, the code block. It's a little bit more elegant than the for loop, because for a for loop you have to declare an index and then you have to take into account the array. In this one you just have to specify an element and a data collection. So it's a little bit more elegant, but the problem is it's a little bit inflexible. So the way a for each loop is used is that it'll cycle through every single element of the array, regardless of where you start or where you end. But if you use a for loop and you don't know where to start or where to end, then there's an issue. So that's what makes this a little bit more elegant. Also, it takes a shorter number of characters, which is a little bit nice. So again, it works in the same functionality as a for loop that goes through the entire array. So I'll just test this one. In this one, I just made it to give random numbers between 1 and 20. And as you can see, it works just fine. But if you want to use something that partially loops through an array or loops through a certain section, then the standard for loop would be a lot better. So the next topic on arrays is array list. So array lists are a data type on their own. They're not an extension of arrays. They're very similar and very different from arrays. Array lists are a bit preferred because, as I said, arrays have a definite size. You can't change them unless you change the code itself. However, with array lists, they're very flexible. They increase and decrease their size automatically. So in an array, like I said, you'd have to copy them into an array that's a larger size if you want to modify it. So let's say you're working with a database and a new entry just arrived. Well, then you're going to have to copy every single element that was already in the database into a larger size database, and that's very risky, right? But in an array list, it'll automatically accommodate for it. It has theoretically infinite length, is what I'm saying. However, the downfall to arrays is that they only work with objects and they don't work with primitive data types. So they're a little bit hard to deal with at first, because then you have to use stuff like capital integer or capital double instead of the normal ones that you're used to. So because of this, arrays come with a set of methods that are exclusive so they can deal with these objects. So if you look here, here's the syntax for creating an array. So it's array list followed by these greater than less than signs of whatever your data type is, and the same thing on the other side, followed with parentheses. So they have their own set of methods. So there's add, so you can add elements to the list indiscriminately at any time. I can even do this and then add more to it, and it would still accommodate for it. Or I can delete it. But there's also the remove method, so you can just by code you can remove any entry that has this object value. You can also set an object at a specific index to another object value, and you can also again use for loops with it in conjunction. Note that there's also the size property, which gives the length of the array list of elements that have been declared already in it, not the theoretically infinite length. And there's also the get, so you can get an object value if you from a certain index. Keep in mind that a for each loop would also work with this. So let's get a bit more advanced. So while arrays can provide like a linear list of data, you can also have a grid of data called a two-dimensional array. So it's a matrix of rows and columns, which has, rows R and then column C, and then it has a total of R times C elements. And they behave like normal arrays. They just have it in a grid pattern. It's pretty powerful because you can have a second variable that's dependent or independent of the first variable, and you can map it out very well. This is also how bit mapping works. You can have, because then you can plot every single point. Essentially like 8-bit, that's how 8-bit color works. You have a series of bits that are being projected on a screen. So 2D arrays function a lot like normal one-dimensional arrays, but they're a little bit trickier to deal with. You have to use what's called a nested for loop. So you used one for loop because it only had one dimension to it, but you will have to use two because there's two, one for the rows and then one for the columns. So you also have to think what happens with these for loops. Keep in mind that unlike if statements, nested if statements, the inner function always completes its function first before the outer one, right? So for this one, it'll cycle through every single increment up till this part, and then this will increase by 1. And then it'll cycle again, and then this will increase by 1. So it's important to imagine how the output will look like. So this one, I've just assigned it to the column, give the number of the column, and here's how it looks like. You can, but again, it's also important to discern that you can, what you're doing in this code block that'll affect the output. So this one will just do the rows, so I just switched it. But you can also do crazier things like switching the variables, and it'll give completely different outputs. So it's important to keep track what's going on. So those are arrays in a nutshell, and you have a pretty powerful utility behind your belt once you use arrays and incorporate it with every single other coding technique that you've learned. So this has been Advanced Java Unit 2.